Hello. It's a big day today. Today, we are learning about trigonometry. And trigonometry is wonderful. It's so great. Trigonometry just means measuring triangles. Trigonometry how do you measure them? And relative to their angles, right? So like trigonometry says, hey, give me an angle, and I will tell you the ratios of the sides. Okay. So if you give me a 30-degree angle, I can tell you, hey, if you go across from me or opposite from that angle, and you compare that to the hypotenuse, that ratio is going to equal 0.5, no matter what. Or if you give me an angle is 30 degrees and you go adjacent to me or next to me, I can tell you the ratio of the adjacent side, the length of that side to the hypotenuse, will always be 0.866, which is, this is a 30, 60, 90 triangle, so it's 1, 2, square root of 3. So when we're talking about this 0.866, it's really the adjacent, root 3 over 2. If you put that in your calculator, if you put root 3 over 2, you'll get close to this. Now, so that's what trigonometry is doing. It's saying, hey, there are relationships between these angles and these side lengths. And, if you know that you've got a right triangle, then we know, well, we don't know, but your calculator knows all of them. Well, how would you get your calculator to tell you these ratios? Well, your calculator has wonderful functions built in. They have a function called sine, which looks like this. And sine will tell you if you give it an angle, any angle, so here we'll say angle A, right? This ratio, opposite over hypotenuse, is equal to sine of that angle. Now, sine is literally just somebody went through for every triangle and they figured out the ratio for those sides. Okay? It's if you can imagine this, before they had calculators, they used to have a table, a big long table, right? It had a big long table and it said 1 degree, 2 degrees, 3 degrees, right? And it said, hey, if you have sine of 1 degree, your ratio is what would it be? It'd be close to 0. Okay, because if you had 1 degree here, think about that. Actually, I can show you. If you had 1 degree there, let me erase some of this stuff I wrote. I want to erase it. Yeah, there we go. If you had 1 degree, I erased some of my, whatever. If you had 1 degree there, I'm going to make this small. You can see sine goes close to 0, right? Because this side gets so small and the hypotenuse kind of stays the same, that we're really getting small, right? And then as that angle gets bigger, your ratio gets bigger. And actually the biggest it can ever be is 1, because then, like, look at that. We're almost looking at a square now. That's a really big triangle. So why is it that the biggest it can ever be is 1? That's a good question to ponder as you go through this lesson. Okay, so it used to be, the important thing to realize is that, like, sine and cosine, and because if you wanted to know this number, that is equal to cosine of whatever angle you have. And I'm using A here But really what whatever this angle is, we're going to use the word theta a lot, which is like a 0 with a line through it. And this last one is called tangent. So you have these things, they're a little bit different than what you're used to. They're a little bit different than what you're used to, but they're not magic by any means. So if you can imagine, before you had a calculator, you would say, hey, I've got an angle. It's 33 degrees. I want to know the ratio of the opposite over the hypotenuse. You would go into a table and you say, okay, opposite over hypotenuse is sine. There's something you have to memorize. You have to memorize that sine is opposite over hypotenuse. Okay? So you'd look that up. You'd be like, I want to know the ratio of opposite to hypotenuse. You'd look up 33 degrees in your table, and it would tell you, hey, that ratio is going to be 0.545. Now, we have calculators, which is a good thing, but I feel like in this case, it's a little bit of a bad thing, because it's really easy to not understand how simple sine, cosine, and tangent are. I think a lot of times students will want to know, like, what is going on with this button? Like, it seems like magic. Whereas if you were just looking up in a book, I think you would realize that it's not magic much more quickly. Okay, so you could figure that out. And then let's say you figured it out, right? Well, what would you do? You'd be like, well, hey, I know that that's opposite of our hypotenuse. So if you know one of these lengths, then you could figure out the other one. Cosine is just adjacent over hypotenuse. So cosine is adjacent over hypotenuse. And so if you knew that this angle was, here, let's change it up a little bit. Let's say that you knew this angle was 6. Oh, this triangle's getting too big. I'm going to make it a little smaller so we can see it. If you had some triangle, and let's say, I wish I could, I don't like that angle. I'm going to make a smaller angle so we can see the side lengths. There we go. So if you knew you had some triangle, and you knew that this angle was 26 degrees, and you were like, hey, I know that the hypotenuse is 10, but I want to figure out how long the adjacent side is. Well, then you'd be like, well, I know the angle and the hypotenuse. I want to find the adjacent. I need the relationship between the angle, the hypotenuse, and the adjacent. Well, cosine is the relationship between opposite and adjacent for any given angle. So cosine A is the ratio here. Okay? So all we're talking about is these functions. You put in an angle and it tells you what is the ratio of those sides. And if you know one of those sides, you can figure out the other side. And then tangent is the last one. And tangent is the ratio of the opposite side. So from our angle, the opposite side is always the one across the triangle. Remember, like if you are at the angle, we call it the reference angle. It's like, hey, I'm over here by this angle. I've got one side that's close to me. I've got one side that's the hypotenuse. I've got one side that's way far away, way over. This is so hard to do. There. The one way over there is the opposite side. It's opposite of me. And so if I wanted to know what's the ratio of this close side, opposite side divided by close side, opposite over adjacent, then I would use tangent. Okay? That's what trigonometry is. It's just inside your calculator, there's a whole list. It's not doing any calculations. It just have all the stuff. It just has all of the values stored in there to a high precision. And you put in an angle and it tells you the ratio. It just looks it up and it tells you. And so that's all trigonometry really is. So we're going to do, keep this in mind, because we're going to use this to do some calculations. The last thing you need to know up here is, what is tangent? Tangent is opposite over adjacent. And the way that everybody remembers it is they just say SOHCAHTOA. You say SOHCAHTOA. You just say that, SOHCAHTOA. And you go, wait, what is sine? And then you go, right, SOHCAHTOA. So, S-O-H. It must be opposite over hypotenuse. And then you go, wait, I need to figure out, all right, which one does opposite and adjacent? TOA, tangent does opposite over adjacent, right? So you just memorize this. It's very, very useful. And then know that means that the tangent button on your calculator will tell you, if you give it a degrees, it'll tell you the ratio of the opposite and the adjacent. Same for cosine with adjacent over hypotenuse, and sine for opposite over hypotenuse. All right, let's do some work with this. Before we go too far into the nitty gritty, I'm just going to have you think about, there's a solve it on the next slide. Think about that on your own and see what you come up with. See if any of this stuff makes sense to you yet. And then after that, we will start calculating stuff and setting up ratios and, doing the pencil and paper work. Don't lose the concept. Don't lose all of this stuff. If you think about this until this makes sense, you'll be in very good shape.